Now let's solve the second question. The second question is right there. Rain is falling on a poorly designed 150-meter square flat roof on a contemporary home. The design flaw requires the water level on the roof to reach approximately 5 centimeter above the plane of the roof before the water flows into drains. I mean, if you draw the home, when I'm trying to draw a home, suppose you have a home like this. This is the roof, and the roof was poorly designed. I mean, if water falls in the roof, the water will not fall into the drain or into the ground, because the water is gonna accumulate 5 centimeter. It is mentioned in the question right there. Look right there, 5 centimeter above the plane of the roof. That means the rain gonna fall into the roof and water is gonna accumulate till 5 centimeter, then it will start to fall. So let me try to draw, like this is 5 centimeter. I mean, I have a very bad hand of drawing something. So let's say this is 5 centimeter. This was our roof, I mean home. This is our roof and this is 5 centimeter. This distance is 5 centimeter. So water is gonna fall into the roof and the water will start accumulating till it reaches 5 centimeter, and after that the water gonna fall out of the roof. So it is obviously poorly designed home, because if the home was well designed, then if any water falls into the roof, the water must fall into the drain. So in the part A of the question, taking the accumulated rain on the roof as the system, can the process before the water level reaches 5 centimeter be considered batch, semi batch, or continuous? Is it transient or steady state? Once the water starts to flow into the drains, how do you answer changes? Okay, let's solve the part A. We need to actually understand the processes. If you know how processes are defined, how states are defined, then you will be able to answer that. So let me just review it. In a batch process, the feed is charged to a vessel at the beginning of the process, and the vessel contents are removed sometimes later. So that is our batch process. In a continuous process, the inputs and outputs flow continuously throughout the duration of the process. So this is our continuous process. Now the last one is semi-batch process. Semi-batch process is any process that is neither batch or continuous. These are our three processes: batch process, continuous process, and semi-batch process. If the values of all variables in process changes with time, the process is said to be in transient state. But if the values of all variables in process do not change with time, the process is at steady state. Now you can ask me, what are process variables? Process variables are like temperature, pressure, mass fraction, etc. So in the part A of the problem, you can see they have asked, taking the accumulated rain on the roof as the system, can the process before the water level reaches 5 centimeter considered batch? So it will obviously be a batch process. It will be a batch process, because when the height is not 5 centimeter reached yet, the water is going to accumulate. When something is accumulating, nothing is removed, water is not falling, it is still accumulating till 5 centimeter reaches. So before it reaches 5 centimeter, the process will be batch process, because there is a input rate but not any output rate is available. Output flow rate is not there, output is zero. So as water is accumulating, so the process will be called as a batch process. Okay, and it will be in transient state before it reaches 5 centimeter. Why transient state? Because the mass fraction of the water is increasing. You can see initially there was no water. As time goes on, the water keeps falling, and the height of the water is increasing, and the water is increasing, so the mass fraction of water in the roof is increasing. As mass fraction, a process variable, is increasing, so we can say that the process is in transient state. It is not in steady state. Okay, so the process in transient state. So the first one will be batch, transient. Now, okay, once the water starts to flow into the drains, how do your answer changes? Mane, that means, when, look at the question again. Right. Once the water starts to flow into the drains, how do your answer change? I mean, when water is accumulated enough, I mean, the water level reached 5 centimeter. Now, if any rains falls, the water is gonna fall out of the roof, right? I mean, waters have accumulated at its highest level. Now, no more water can accumulate. So, if rain falls now, so the water gonna fall out of the roof, right? Now this time the equation will be like that. I mean, there will be an output flow rate this time, because as rain is falling into the roof, this much amount of water should remove from the roof, because water is already accumulated at its highest level. No more water cannot accumulate, so the process will be continuous. Why the process is continuous? Because there is an input flow rate, and as is an output flow rate. And in this particular example, the input flow rate and output flow rate will be equal. In this example, the input flow rate and the output flow rate will be equal, because no water is accumulating. The water falling to the roof must also fall from the roof into the drain. So the process is continuous, and this time the process will be in steady state. Why in steady state? Because the mass fraction, I mean the process variables, are not changing this time. Temperature is fixed, pressure is fixed, and the mass fraction of water is not changing in the roof, within the roof. So the process will be in steady state. Now moving to the part B. Before the water starts draining, which of the terms in the general balance equation can be omitted? Why? How do your responses changes after the water starts draining? So let me first write the general balance equation. Input minus output plus generation. I am denoting G as generation term, minus consumption. Consumption is represented by C, equal to accumulation. Accumulation. So in this example, no reaction is happening within the roof, so the generation and consumption term will also be zero, like in the first example. So the generation and consumption will be zero, as there is no reaction occurring within the roof. So we are left with input minus output equal to accumulation. Now output is also zero for the first case. In the first case, the water was trying to reach 5 centimeter. It is not reached 5 centimeter yet. I mean, taking the before the water starts draining. I am taking before the water starts draining as a system. So output is zero, because no water is falling before the draining. So output will also be zero. So we are left with input equal to accumulation. That is our final equation. Now the next part, how do your responses change after water starts draining? I mean, after water starts draining, there will be an extra term added, which will be the output, because this time output is there. After the water starts draining, there will be some output of water. So the next part, output will be added. So input minus output equal to accumulation. And here accumulation term is a constant, because uh, accumulation is like a constant. I mean, there is a certain level of water that can be accumulated, not more than that. So we are done with part B. Now moving to the part C of the question. Let me erase it. I don't think we will be needed these data again. Now moving to part C. Water begins flowing from the roof after 30 minutes of rainfall. I mean, the rainfall is going on, water is accumulating. After 30 minutes, 5 centimeter level is reached. Water has reached 5 centimeter of level. That means after 30 minutes, if any more rainfall happens, the water gonna fall out of the roof. So water begins flowing from the roof after 30 minutes of rainfall. What will be the rate of draining? I mean, what will be the rate of draining means output rate in liter per second. You are asked to find out the output rate in liter per second, be if rain continues to fall on the at the same rate. Okay, obviously the output rate and input rate is same. So let me read out the question again. Water begins flowing from the roof after 30 minutes of rainfall. What will be the rate of draining B if rains continues to fall at the same rate? So the area of the roof is given, A equal to 100 meter square, right? We can convert it to uh, let me first convert it to centimeter square. So if I want to convert it into centimeter square, it will be 10 to the power 4 centimeter square. Now the height is 5 centimeter, h equal to 5 centimeter. So the volume will be A multiplied by h. So the volume of water will be 150 into 10 to the power 4 into 5 centimeter cube. So the answer comes out to be 150 into 10 to the power 4 multiplied by 5. That is a huge answer. If I want to convert it to liter, listen, the volume is in centimeter cube. If I want it to convert into liter, we have to divide it by 1000. So if I want to find out the volume in liter, we have to divide this equation by 1000. So that comes out to be 7500 liter, because cubic centimeter is equal to mm, right? Ml, sorry, ml, milliliter. So you know why we have divided it by 1000. I mean, you will be able to understand it, I think that. So we have found out the find out the volume that is required. So if I want to find out the volumetric flow rate, we have found out the volume of the water. I mean, we have found out this volume of water. Now if I want to find out the volumetric flow rate, so I have to do V dot. Dot means flow rate. If you see a dot on some letter, you need to understand that it is a flow rate. So V means volume, V dot means volumetric flow rate. So there will be a time related term in that. So volumetric flow rate will be 7500 liter divided by 30 minutes. So 30 minutes means if I want to convert it to seconds, so 30 multiplied by 60, that will be our seconds that is required. So the answer comes out to be 4.167 liter per second. So that will be our required volumetric flow rate. That will be our draining rate. So at this rate, water is falling into the roof, as well as falling out of the roof. So draining rate and rain falling rate are same, and the value of this is 4.167 liter per second. So we are done with our part C. Now let's move to part D. The homeowner is considering installation of a green roof that is partially or completely covered with vegetation. Vegetation means vegetable plant or something like this. If this is done, how would you answer to parts A and part B change? At least two concerns and two environmental benefits of the new roof. So how does a green roof look like? So I have taken a picture from the internet. This is how a green roof looks like. Green roof means I mean you can plant some uh, plants or trees in your roof, that is called green roof. So if there is a green roof applied or installed, so in this case there will be some consumption of water. Why there will be consumption of water? Because the plants in these roofs gonna take some water for their photosynthesis process or something like that. I mean there will be some water consumed. So in the before, I have erased this. In the mass balance equation, the mass balance equation was, let me write it again for you. The mass balance equation was input minus output plus generation minus consumption equal to accumulation. So in this example, consumption will not be equal to 0. Why consumption is not equal to 0? Because the plants are going to take some water for their photosynthesis process or something like that. I mean water will be used, some water will be used. So consumption term is not 0 in this example. So that is the change, one change you can apply. So other concern and environmental benefit, I mean it is up to you how you can think. So I'm not gonna answer the next part. It is up to you, the environmental benefits and the demerits. So that was our part, that was our 4.2 number of question. See you in the next problem.